So we're going to use Excel in order to answer this binomial distribution problem. Suppose that 5% of the first batch of engines off a new production line have flaws. An inspector randomly selects 80 engines for testing. We wanted to determine the probability distribution for the number of flawed engines in the sample. So we can have as few as 0 successes and as many as 80. And by success, I mean failure. So that we're going to consider the number of failures, the number of successes in this case. So I'm going to cursor down, drag this down to 80. And the probability, what I'll do first is I'm going to format this as a table. And so our probability is going to be equal to the binomial distribution. And the number of successes will be 0. And the number of trials is 80. The probability of success, I can either put in 5% or 0.05. And I don't want the cumulative frequency. So I'm going to put in false. And so now we have our probabilities returned. And next it said create a frequency histogram to illustrate the distribution. So I'm going to click anywhere in the chart and insert, and I'll select chart. Now again, this is a constant problem when you're dealing with a histogram. So double click and select data, and I want probability to be on the y-axis. So I'm going to remove that from the number of successes and click OK. And so now I've got this frequency distribution, the frequency histogram. You'll notice that we have a peak here that corresponds to 4. And it's the fourth point, which is the fifth point, which is actually 4. So now if I want to now answer the next question, which was what is the expected number of flawed engines in the sample? Well, that's going to be equal to n, which is the number of trials, which was 80, times the probability of success, which is, again, failure, which is 0.05. And so your expected value is 4. So your expected number is 4. So if 5% of the engines, the probability of failure or flaw is 5%, then out of 80 engines, you'd expect 4 to be defective. Now, this distribution shows that you have very few, you can barely read any numbers beyond about 13, 15, and so forth. And then they seem to be non-existent beyond around 20. And so looking at the numbers here, okay, so this is, the probability here is 1.55 times 10 to the negative 9 as far as the probability of having 20 flaw or 20 defective engines. So it's very low. And the last question, what is the probability that the number of flawed engines is greater than 6? And so greater than 6, the way we can do that is we'll take the sum and we have to select from 7 up. to 80. And so the probability that you're going to have greater than 6 engines as being defective, meaning 7 up to 80, the probability is around 10%. So now, when you create a histogram, be careful here, because I almost missed it. When I created my histogram, the horizontal axis actually just corresponds to the first point, second point, third point. It doesn't actually match up with the number of successes. So what you can do is you're going to click on Select Data, and I'm going to take here the number of successes. And there we go. And press OK. And so now you can see here the first point is matches up. So when I hover over it, I get there. So 0.0, that matches up with my probability up here of 0.0165. So now everything matches up. And another thing to notice here is the probability at 0.4, which is 4 successes, is our greatest value. And that makes sense because here is our expected value of 4. And so that is going to be the most likely or the most probable outcome. So because 20% of 80 is 4, that's the number of failures, or in this case, number of successes that we expect. And you can see that 3 is very close behind, where it is just about 20% chance of happening. So between 3 and 4, you're looking at about a 40% probability that there is 3 or 4 failures.